What are you guys doing sleeping on the floor?
Taking over every job, so we're just sleeping.
Yeah, and we're using our time super wisely. Now get out!
Guys, sleeping isn't the answer.
What are we supposed to do?
Well, you're in luck because we're going to invite someone who can tell us exactly that.
Our journey into the future continues with the second segment of our Future of Work series, focusing on AI infrastructure. Leading this discussion is Sunil Ranka. Sunil is a true achiever in the field of technology, with a unique talent for anticipating future trends and spotting opportunities. This has led to a successful investment in over 32 startups. Currently, he's using his knowledge and wisdom as founder of Predictly, an automation and efficiency-based company based in Silicon Valley and Pune, India. Let's welcome Sunil Ranka.
Thank you, guys. So we are going to talk about future of work AI infrastructure. Please welcome the panelists for today. Sanjay, Shekhar, DJ, and Shrini. Please give them a big round of applause. Okay. Usually it's hard to get a panel during the lunchtime, and we'll make the most out of it. So I think we have very few people. So if you guys don't mind coming in the front, that'll be easier because we would love to see if we can interact a bit more with the crowd. Myself is Sunil Ranka. I run a company called Predictly. We are into automation and AI space. And today we have a privilege to talk to a few of the esteemed panelists today. They have done a lot of work. So let me introduce Srini. He's part of Onto. They do a lot of manufacturing for the chip, and I think he's going to bring in a perspective where how the evolution of chip has begun to get to a point where the AI is getting supported. We've got DJ. He works for Microsoft, part of their AI team. And how many of you have heard about ChatGPT? Okay, so quite a few. So he's helping Microsoft today scale it up to the level where we need to be. We've got Shekhar. He's a serial entrepreneur. Shekhar, I could not keep track of how many companies you have sold, but he's part of, I think the latest was Sky High, acquired by McAfee. And he's part of Berkeley's Skydeck. And I think the perspective what he will bring in today is about, where the industry is moving and where the investments are happening and what kind of opportunities what you're seeing. And then we've got Sanjay from Trinamics. They are on a specialized Oracle partner. They focus on supply chain. And I think one of the areas where we are consistently seeing need for evolution is because if you take the pandemic, supply chain was the biggest disruptor. And if we did not have the right supply chain, half of the world would have gone hungry. I think that's where AI could make a larger dent into the place. So I think this is going to be we would love to keep it more interactive just in case if you have a question during the conversation, feel free to raise your hand, come in the front, and we'll be more than happy to have the interaction. So with that, Srini, I think one of the interesting piece when we met yesterday, we were talking through, and he brought in a very interesting point that, who's the audience? And the audience is the young kids, people with a different background, immigrants, or the first generation. And we all talked about the life is all about being a computer science engineer, medical, or being a CPA accountant. But Srini brought a very good perspective that the way that things are moving and the way that things are evolutioning in the chip sector, there's a lot of bigger opportunity. So Srini, if you can spend a few minutes talking about what you have seen from the growth of what we used to call the CPU, and now the darling of the market is GPU and the NVIDIA. And so if you can just talk us through what are the different opportunities young kids can get into, that'll be great. And if you can just talk through the whole evolution of chips. Can we get this mic on?
Yeah, it's on. Thank you. So thank you for the question, Sunil. So I represent the chip manufacturing and chip production industry here on this panel. The semiconductor industry, or basically everything that you see in terms of advancements from your smartphones to your laptops to now with artificial intelligence, everything gets enabled with the latest and greatest generation of chips, right? So these are chips that do extremely complex computations, as well as the storage requirements and the fast communications that are needed to drive some of these applications. The industry is actually very mature, very old. The first transistors came out in the 1950s, and everyone has gone through, many of us at our age have gone through the PC era, then the mobile era, the data era, and now we're talking about artificial intelligence. All of this got enabled by essentially what we in our industry call is a law. It was called the Moore's Law. And Moore's Law basically stipulates that every 18 months, the chips that we see tend to get 2 times better and 2 times cheaper, right? What that means is a lot of the computations that we do today, right, are going to get faster, they're going to get cheaper, which then enables more and more applications to come out. Likewise, artificial intelligence has been around for actually a long time, right? So back in the mid 1940s, right, the very first question was asked about, how could you distinguish between a human and something that's not an automated response system? In the 1990s, that evolved into neural networks and some of the associated algorithms. But why we are talking about AI right now is that both of those innovations in the evolution of the mathematics and the computations, as well as the compute needed to run those, they have now come at a juncture where you actually can make those possible, right? So we talk a lot about artificial intelligence, and there's a lot of nervousness among all of us as parents. What happens to jobs? Do our kids need to go into data science? Do they need to go into machine learning experts? Not everyone has to do that, I'll assure you. The chip manufacturing industry is extremely complex. In general, it takes anywhere between 16 to 24 weeks to start from the basic raw material to actually come up with the final product, right? And every chipset that you see has billions and billions of transistors that have to go through extremely precise manufacturing processes. So you need chemical engineers, you need material scientists. I myself as a chemical engineer, and I build highly advanced microscopes. Electrical engineers, we actually use a lot of AI in our own equipment to be able to predict our customers' manufacturing processes. So I think the core for the industry and for the future generation is to, first, I think there were a lot of good commentary early on in the sessions about keeping your minds curious, being able to learn, getting the foundations right in terms of your, in sciences, in mathematics, and be flexible. There is not just one avenue to be successful in this, in the upcoming future. You can do a lot, and a large array of industries need to get revamped and overhauled. And yeah, so from a chip manufacturing perspective, our goal is to get you guys the latest and greatest chips that you actually can build all these applications.
So what does it mean? It's not just about the computer science or computer engineering. There's a huge potential in terms of getting into electrical engineering, chemical engineering, material science, and a lot more other areas. And so AI is going to make you more efficient, doesn't mean it's going to take away the job. So I think the greatest example, what we all talk about, is back in the days, there were wagons with the horses, and the cars came, and people said that those people will not have a jobs, but they have to retrain themselves in an ecosystem which was more relevant in terms of the past experience. So jobs are always going to be there. It's just that it's going to get much more efficient, and people have a bigger and a better opportunity. That leads to our question, DJ, which is, we looked at the cloud evolution. We looked at people. I remember back in the 2000, right? When we came, right, we spent like $2,000 buying a computer at home. You go on Dell, configure it, bring it back. And then one fine day, I read an article, which was a very interesting article, which said owning a computer for 50 cents. And I was like, wow, that makes sense. And then you go on Amazon, you just rent a computer. You don't use a compute, but you own a computer for 50 cents and you start utilizing it. So that's the evolution from the hardware perspective I've gone in. and you are in the center of this situation, which is 18 months back, nobody could have thought that 60 engineers will give Google run for their money. And that's the inception of Sam Altman's, what we call the poster child of AI today. And that has helped a lot, like as an application in companies. You are in the middle of that, which is you are helping Microsoft get to the scale which is needed. Can you just describe what evolution you have seen from a pure cloud computing to needed cloud computing for an AI piece? Can we get the mic on?
Am I audible? I want to just touch base on two fundamental aspects. First is not even related to cloud computing. It's about shared economy. Before 2000, before internet became popular, before everyone had their own cocoons of investing, we didn't have a lot of shared economy. By shared economy, I mean in the beginning of 2010, 2005, that era. And that's when AWS also had their inception. We had this concept of how can we share cars? How can we share home? That's the birth of this Uber, Airbnb, all of this. And that's when Amazon, group of engineers, I think it was less than 60 engineers that thought, hey, to run our Amazon Prime, we have a lot of this capacity, and we are building up all of this capacity to just run the infrastructure services that are needed during the peak time. What is the peak time? The holidays, Christmas, all the gifts that you all ask for your parents, right? So Amazon had to build up this infrastructure so that the Amazon page would actually not show any kind of 404 not found, mainly because of server infrastructure not sufficient to handle all those requests. But keep sending those requests to Amazon because they have this amazing scale now, mainly because they're not only just building for their customers, but they're actually making it even wider because they said, okay, all this extra capacity, we would sell it to the whole world and make computing cheaper so that the likes of Sunil who wanted to establish companies don't need to spend $2,000 per computer, but can actually get it per day, 50 cents. And he could actually choose to not use them. And that was the birth of cloud computing. How can I rent my additional infrastructure for the whole world so that I can keep on building and scaling? And soon Microsoft, Google, and many other companies followed the suite. And 2014 and 15 was an interesting time when hardware had to catch up with the software. We all heard about data science, but that's the birth of the era of data centers. Data centers are these buildings that house the server infrastructure, which cost billions of dollars to build, which host millions of servers across the world. And we have seen a plethora of different applications that need to be scaled. And I work on problems of how do we build hardware or infrastructure that support the software. And so hardware and software, which were actually diverged concepts, became more and more supportive to each other. And what we call in the cloud industry as hardware and software optimized architectures. And GPU or hardware accelerators are one of them. GPU is one of the type of hardware accelerator that could enable cloud computing type of workloads. And in the same suite, we have ASICs, we have other things coming up in the future. The future is bright in terms of technology. What I would say in addition to what Srini mentioned is 50 years back, our engineers are busy building the city infrastructures, road infrastructures, wonderful buildings, bridges, whatnot. Now, we also need to build. We need to build the data centers. We need to build the cloud infrastructure. And that is the basis, is going to be the basis of the economy in the future. So for data centers, we need pretty much the same kind of engineers. We need electrical engineers. We need civil engineers. We need thermal. You need to really understand the concepts of heat transfer in your thermodynamics classes, right? And you need network engineers, right? And you need, of course, you need software engineers. So the future is bright for the kids. It's similar kind of field, but with a focus on different applications now, building data centers and cloud infrastructure on top of everything else that we are building for the betterment of the economy and improving the social mobility across the world. Any other things?
No, this is the very interesting because I think we got to a point where we understood where the evolution of the chip is. We talked about the cloud computing, shared economy, and that's where the Ubers of the world and DoorDash of the world. I strongly believe. I was talking to my dad, and my uncle who's my neighbor. He graduated. He worked at the same place for 32 years, and they took pride in that. My dad, worked for like 8, 10, 15 years, and that was the loyalty system. When we started the job, we said, okay, if you don't stay with the company for 5 years, right, that's not called the loyalty. But now, with the changing piece, right, a year and a half, 2 years is what the people are looking for the opportunity. My belief system is 15 years from now, very few people will do a 8 to 5 regular job. Everyone will have a couple of jobs, and you'll be so efficient in the world with your, what do we call it, like co-pilots of the world, or the AI assistant, that you will be doing 4 hours of coding, 2 hours of barista, 1 hour of, playing a piano, and you will still have a very healthy life in terms of the way you want to live it. So the technology is not going to add a lot of pressure on you, but technology is going to give you an opportunity to be more efficient so that you can do what you like to do in your free time, because technology will give you that aspiration. Now, it's a perfect segue, Shekhar. I mean, you have built companies, sold companies, you have cashed onto the way when people talked about data, people talked about infrastructure. Cybersecurity was at prime. Today, if you look at it, every conversation when it relates to AI is how do we protect? How do we ensure that there's no cyber frauds are happening? I learned a very interesting piece, which is, I think 2 days back, Bangladesh, which is one of the, not the most efficient economy in the world, there was a situation where they sent an email, a, a CV came, they clicked on it, they would have siphoned $1 billion from one bank of Bangladesh. Irony was a human error, so that money did not go through, because in the SWIFT, they put a wrong, the SWIFT number. The point here is, with this whole AI, so much of data getting gathered, where do you see the opportunity and where the industry is moving towards from an AI perspective, and keeping a little bit of infrastructure view if you can,
Yeah.
but keeping the cyber in mind?
Yeah. Let me give you my perspective. I think AI, a great segue actually, because you talked of hardware and the infrastructure, which is layer between hardware, software, and what's the basis on which you build these AI apps. And I think there's a fundamental shift. If you think about the last 10 years, there was this whole notion of software as service. So all of us are familiar with it. Salesforce, Office 365, every application has become a service. And it's interesting that those software as services used by humans to make their jobs easier, better, and so on. That's, I think, gone a long way in helping the economy. But what AI is doing is actually flipping that a little bit. I think it's making, rather than software as a service, it's service as a software, which is really, if you think about what humans do today, we offer a service, right? Every one of us is offering some service, and software has helped us to make it easier. Now, with AI, the promise is that AI itself will offer the service. You don't need a human. The AI can go and close your books maybe, or maybe do customer support, lots of different things. So it's going from today what we call co-pilots to, in some sense, autopilot. And so that fundamentally shifts a lot of questions, opportunities. And as a entrepreneur, person who's looking at a lot of different technologies, it's a great time to be creative and innovative. But that doesn't mean that it is not going to fundamentally shape the economy. Because if you look at what services software is going to do, right? Software as a service, the current platforms, it's about a $250 billion market. if you're saying that AI is going to take on the services, and the service meaning what humans do and so on, which is the biggest cost. It's about a $5 trillion for knowledge workers. So AI is going after this much bigger pie, and in some sense, it's sort of collapsing all of that. And it's going to become autonomous potentially. There's a lot of interesting, going back to security and privacy, all of those, there's a lot of interesting challenges which come about, right? So if autonomously you can make decisions, are decisions being made, in an ethical manner, for example? So let's say autonomously you're driving, I mean, this is a classic thing which kids learn in school as well, is there's a train which is going, in a track, and there is a fork in the track which can go in one of two tracks, right? One track, there is a human, who's stuck. Another track where there's a animal, right? Now, as somebody who's driving navigating that train, they choose which direction to go, and sometimes they use ethical decisioning as humans to make a decision. So if you're going from co-pilot to autopilot, what is that ethical computing requirement which need to be embedded in that whole, making AI more pervasive? So that same thing, if you think about autopilot as the concept, generally speaking, it's a big issue with even defense and how countries protect themselves. And if you look at almost all wars today, it starts in the cyberspace. It's very easy today. And in fact, every so often you'll see hackers try to play around with your grid or your water supply system, all of that, right? And if the adversaries use automation and AI to attack you, then your response times cannot be at the speed of human responses. So it's really, for older folks who look at these comics called Spy versus Spy kind of thing, it's really AI versus AI is really where a lot of the discussion will head towards, I think. And finally, I would say, and there's more we can drill into from a cyber perspective, but finally, I would say that given that you will have potentially autonomous, autopilot kind of, services which are offered by AI, humans are going to be in work environments. Today, we talk about hybrid work, where you're saying work from home and work from office. Hybrid work in the future will be humans working together with virtual agents. And so that's where I'd leave it.
Yeah, perfect. I think you brought a very interesting point. We just evaluated one concept where the person came back and said, hey, you know what, the actual housing market in US is $16 trillion. But the rate at which the interest rates are going up, that $16 trillion market, there's a bigger funnel, which people are just sitting on the fence. So what Robinhood did to stock, which means the retail investor got into Robinhood phenomena, and then GME and AMC, what we saw. Using AI, you could bring in the folks who are on the fence, and you can literally kickstart an economy, which means, like, today, if I can't afford a home, but if AI can help me decide that these are the 5 things you can do, and these are the areas, and this is kind of a particular house you can own with your current W-2 or 1099 your investment. That's knowledge used to be with very sophisticated people. And now if you can replicate that brain, you can upscale the economy to the next level. So the $16 trillion economy, you might have another like $2 trillion dollars sitting outside. They're not getting to the 16 trillion. That's where, the whole AI piece is going to scale the economy. Now, this brings back to the point where, we all talk about the concept, we all talk about the theory, we all talk about the vision, right? You are at a core today, Sanjay, which is you have taken an old application, which is like Oracle, which transformed the world, competing with SAP back in the days, became the poster child of application in United States because we are competing head on with SAP in Europe. you are dealing with supply chain, which is, in my opinion, is one of the most important aspect of the world. You take the Red Sea situation, supply chain gets stopped, the prices go up. You take any geopolitical situation, if the China decide not to ship anything to us, the problem is we are going to pay price for it. Supply chain is very important at a core level, right? Forget about concept, infrastructure, scalability. There's a whole concept of data, structured data, unstructured data. And I've been through 3 cycles of AI, BI, big data, where the actual application is happening as we speak today. Because AI is hard. Not everyone understands it. Where you are seeing people are really utilizing AI at a fundamental level.
So from a AI perspective, right? As Srini mentioned, AI has always been there in the market, right? Earlier on, it was at a lower level, but last 3-4 years, we have seen the pace to be very, very high. A lot of people are trying to get efficiencies from the business processes. Let's take an example of you talked about unstructured data, right? For example. Now, if someone has to find if someone has to find a contract, which is like tens and thousands of contracts in a company, and I have to find how many contracts are linked to a particular company. That's a word search, right? Within 200 contracts, each contract 200 pages. You can imagine it's like a pile of pages from here to here. So how do you try to unearth that? So that's where AI comes into play. So basically what we are seeing is people are trying to find case studies where the business processes can be improved, the efficiency can be imbibed on. So that's one example of a unstructured data. But the other example of a structured data maybe could be, say for example, I give you a scenario, right? Apple iPhones, right? Everyone owns iPhone. Now there's a lot of supply chain behind it. How much of iPhone should be stored in Bay Area warehouse? How much of iPhone should be stored in nearer to the manufacturer? How much of iPhone should be stored closer to the customer? Where is the customer? So all this goes into an algorithm, which is very difficult to solve. And that's where AI comes into play. So we kind of on the application side, we are trying to see what we are seeing is all these corporates, they are questioning how much should I store, where should I store, and what are the different parameters around it. And by the way, there is not one parameter, there are tens and thousands of parameters. So that's where it becomes a complex problem to solve, and that's where applications is coming into play. And people are essentially focusing on how do I solve my business problem. Business problems could be so many, and that's where we are seeing the.
So I think what you're saying is with the inception of AI, which was harder. So we recently interacted with a group which deals with the dental. Their problem was very simple. When they send a paper out, they needed to know whether its a signature is there or not. So the way they were doing it, when we visited their facility, they'll take out the printout of each and every paper, stack it, somebody manually does it. And the way, DJ, you scale up your computing during the holiday season, they do the same thing before December 31st, because that's the prime time when a lot of people are trying to utilize their dental insurance. And it was, okay, you give the paper to us, we will run a very simple computing mechanics. It may not even call AI. And we'll just try to identify if there's a signature on the page or not. If not, we send it to the human. And human can say, okay, this particular paper does not or does have it. Or in some cases, right, the signature is moved up and down. So rather than looking through like close to like a 3 million pages, all they had to do was 30, 40, 50, or 100,000 pages as the application got matured. I think that's what we are seeing. And the beauty is the problem which we could not solve a few years back, with the inception of LLMs, we are able to solve it at a blip of a piece. So that's pretty interesting. I think we have got a few more minutes. So I think one thing which I want to bring to everyone's attention is, I think we briefly spoke about the CHIP Act, right? Like the $52 billion and why it is important for us. I think, Shekhar, you said right? The wars are not fought at a front foot because there's no point doing it because it's expensive. They're fought at cyber level. They are fought at a manufacturing level. The ASM of the world, the 3MCs of the world, the Huawei, the best example of Huawei, right? Back in the days, there was all the conspiracy theory. So we all talk about a CHIP Act, and it's going to be one of the most important pieces as part of the election theory this year. And I believe that's going to be important. And Biden has pushed a lot. Intel has made a commitment to do $17 billion. And of course, there's a right reason behind it. Can you touch upon that? What exactly is that?
Yeah, so maybe I'll connect a couple of the themes that were talked about in terms of innovations that are needed to go from semi-autonomous to autopilot. So first, in the manufacturing industry itself, there's going to be huge value, right? The chip manufacturing industry, just historically, for all sorts of reasons, you got to keep everything very clean. You can't have particles going in. These are ultra clean facilities. We've always had very little amount of human touch points in the entire manufacturing process. You would be surprised that if Intel, spits out billions of dollars of semiconductor chips, they probably only have like 3,000 engineers running some of these mega fabs, right? Mega factories. All those decisions on how to make some of these factories more efficient, and not just for chip manufacturing, for automation, the auto industry, the aero industry, all that will get significantly accelerated with the advent of some of these large language models and such. So interestingly, that as the decision making goes away from humans, the concern always is what threats are we going to create for ourselves? And this is where, for the last 20 years, when there was an entire movement to go from local to global, right? We all heard about globalization and the impact thereof. Now things are going to go back from global to local. One of the biggest national security concerns for virtually every country in the world is the automation of these chips. If these are available and they can only be manufactured in a couple of countries like Taiwan or South Korea, which are hotbeds of a lot of geopolitical strife, how can we become self-sufficient? The United States, back in the early 2000s, used to produce about 35% of the world's chipsets. It's fallen down to 12%, right? So it's really a national crisis issue right now. So what the US government is doing, which will actually benefit a lot of the kids that are growing up here, is over the next decade plus, they're bringing in a lot of investments in, and actually the government of India is doing the same thing by starting to invest a lot. So this $52 billion that was earmarked, it's actually a very, very tiny drop in the bucket. You need to do 52 billion for every year for the next 10 to 15 years, but it's still good. What it's going to do is to create an ecosystem of bringing technology and manufacturing back into the United States, right? The chip design typically tends to be very, very complex. And I think there's going to be a lot of innovations that will come back. And more importantly, the manufacturing of some of these very advanced chips that are used in defense systems, they're used in security applications. All of those need to get back into the US. And those innovations and manufacturing coming back, the inshoring, is going to drive a lot of new opportunities within the academic institution, right? So MITs and Columbia and a lot of these guys are now back reintroducing into their educational curriculum back again, chemical engineering, material science, how to make chips. In addition to that, I see the need to bring in more vocational training, right? The polytechnics that can come in where the hands-on manufacturing processes, how do you go develop these things? How do you go, turn a wrench, so to speak? So I think the need is, I can't recall the exact amount. I think they're talking about 500,000 engineers required over the next decade to bring some of the infrastructure back to the US. That creates a ton of opportunities for the kids as they start to look at future work potential for themselves.
Perfect, thank you. So we are almost close to our time. Any questions from the audience? We would like to take like a couple of them if there are any. Perfect. Yeah, please, can you just come in front, please? Rishi, do you have a mic for him?
So you said that we could get like 50 cents a day. We could get the software, right?
Okay, so yes, we did say that for a 50 cents a day, you could get a computer, which you can utilize it. Yes, so what was your question?
So would it make sense if I would use this or like buy another laptop for like $1,000?
Your dad must be really proud of you. Yeah, so very interesting question. And I think I would like DJ to fill this up. I have a perspective on that, but I would like DJ to say, because I don't want to, because he makes money on usage, so I don't want to take that away from him.
What's your name?
Shamik? Shamik?
Shamal?
Shamik.
Comic? Very nice question, Shamal. So, I mean, no one from the likes of Amazon, Microsoft thought about it. We are mainly providing computing for enterprise users. If there is any kind of server that could help with your Gmail, with your gaming, with your homeworks and all of that. And like Shekhar mentioned, if you can offer a Chromebook kind of service with all of this put together, I think that's going to kind of address what you're looking for. Everything in one package. Like you just need a plugin and you need to pay that 50 cents or $1. But the problem is you will lose your data. So the value add for your laptop is you're having the data with yourself for the most part. And we're trying to bridge that with a subscription service, which probably you'll end up paying the same amount as your laptop because you need to have that data for all your education, which is almost 10 years, right? So you're good at math, so 50 cents every day in the 10 years. So laptop makes sense for every 2 or 3 years. But it's not the same case for enterprises because they need to upgrade their hardware and make it the best performance possible. Just the same reason like you update your laptops, they need to update the infrastructure every 2 years, right? But they can't actually upgrade all the computers in all those offices. So all that they do is a switch of a button and they could upgrade all the hardware without even having to move, right? And that's the beauty of cloud computing. Bigger enterprises, when you actually graduate and when you establish companies and when you want to get new computers for everyone, then probably you could be able to do that, upgrade your software and hardware. Does it make sense?
Thank you.
Any other question? Okay, so with that, we'd like to conclude, but I just want to do one exercise. What comes in your mind, the very first word or a thought when we say AI? Trini.
Productivity.
DJ.
More time to do my things.
Productivity again.
Opportunity.
Opportunity.
Efficiency for day-to-day problem.
Perfect. So productivity, efficiency, opportunity, more time to do things. But so basically what it's saying is AI is not something we need to scare about. It's going to give us an opportunity where we would be able to increase our day-to-day bandwidth. Within the set time of 8 to 10 hours, we will be able to do our work more efficiently, which will give us an opportunity to do things which we like the most, apart from working and putting the food on the table as a family, head of the family. So with that, thank you so much, everyone, for listening in. It's hard during the lunchtime, but thank you so much, and we truly appreciate all the time you gave them. Thank you.